Okay, so taking a look at 14 and 16 from the summer packet, the first thing I notice is that we do have two variables. We have an x and a y, which means if we have two variables, we need two equations, and that is called a system. So two variables, two equations, three variables, three equations, so on and so forth. And so this first one, number 14, is set up really nicely for us to use something called elimination. So there's three ways to solve it: graphing, substitution, or elimination. And so what we do here is we are going to eliminate one of the variables. In this case, our positive 2y and our negative 2y are going to eliminate or cancel. When I add these two equations together, this becomes 0. And again, I can do this as long as I add, the entire left side together and then I add the entire right side together, all fair game. When I do this, I get 3x is equal to negative 5 plus 6, and that gives me 1. When I go through to solve this, I get x is 1/3. Keep in mind that I also have to get our y value, so take that and plug it back into one of the original problems. I'm going to plug it into the bottom one because I am a rebel. 10 times 1/3 minus 2y is equal to 6. So 10/3 minus 2y equals, you know what, I'm going to change this 6 into 18/3 just to make my life a little easier right now. So 18/3 and 6 are equivalent. They're equal to each other, but I know that I am going to have to subtract 10/3 from both sides. And so it's just going to be easier for me to have the same denominator. Okay, so 18/3 minus 10/3 is 8/3. And when I divide by negative 2, I'm going to end up with y is equal to, and these, if I divide something by 3, and I'm dividing something by negative 2, it's the same thing as me taking the 8 and dividing it by negative 6. This simplifies down into negative 4/3. Final answer, 1/3, negative 4/3. And of course, you can take your answer and plug it back in, which is why math rocks. Number 16. I think most of us dislike fractions if my 17 years of teaching experience have taught me anything. So we're going to multiply out the fraction. We're going to get rid of the fraction. And by in order to do that, we're going to multiply by the denominator. In this case, there's only 1. There's only this 3 right here. So I'm going to multiply the entire top equation by 3 to clear that fraction. So this becomes negative 3x. Okay, 3 times 1/3, positive 1y. Okay, and this becomes a negative 18. So just by looking at this now, I notice something funny that's happening. I notice that a positive 3x and a negative 3x, when I add them together, that's 0. And I notice that a negative 1y and a positive 1y also become 0. So if I was to add these together, I end up with 0 equals negative 24. So in other words, that's never going to happen. This ends up being no solution. And what that looks like in terms of a system, because keep in mind, these are just two linear equations, right? These are two graphs. So if I was to graph these, they would be parallel lines, and they would never intersect. So they have the same x and y intercept, right? Sorry, x and y values here, but they don't have the same number in the back. So the x and the y values end up canceling, okay? But those numbers don't, so this is no solution. If the problem turned out to be, 3x minus 1y equals negative 6, and negative 3x plus 1y equals 6, everything cancels out, and I'm with 0 equals 0, which means it's exactly the same, which means it's infinitely many, which means my two lines are right on top of each other.